Batteries are power supplies. Well, more specifically, they are accumulators of electrical energy, but what really does the job is the electrolyte. So the electrons are not just on one side, and that's it, but when you circulate the current, what happens is that the electrolyte repositions them on the output line again. A charged battery is a prepared electrolyte. My teacher gave me these two batteries because he wants to compare them, and in principle they are the same, but one weighs more than the other. So we're going to do all the tests we can in this video. The first thing we see is 9,900 milliamp hours. This means that the battery's capacity is 9,900 milliamps supplied in 1 hour. That's all it takes. That doesn't mean that we can't use it more slowly, with less amperage. The 9990 is the content it has, the capacity it has. They are both 3.7 volts. This is 1.2, which is 1.25 volts, and is 3,000 milliamp hours. That is the capacity. The problem with this is that when you connect it to a device that needs 1.5, because this is 1.2 and goes in places where 1.5 needs to go, if the device doesn't mind if we put 1.2 in it, it will work fine, but if the device requires 1.5 volts, it won't do the job. And that happens in some electronic devices. This is a single 1.5 volt cell. Now we are going to measure the short circuit current. Be careful, because this has to be done in less than 1 second. Now we're going to charge them in parallel so that they charge equally. We have been using them, and we are going to make sure that they stay in optimal conditions to do the test. And in parallel, it will be both at the same time, so that both are in the same conditions. The voltage to recharge a 3.7 volt battery is 4.22 or 4.23, and you should not go beyond that, otherwise the battery could be damaged. As the batteries are charged, the current intensity will decrease until it is practically at zero. Then the battery will be fully charged. Since the batteries were not exhausted, we were able to recharge them in less than 1 hour. I am going to put some 3.8 volt bulbs in, and a current of 300 milliamps will flow. It will give us a power of 1.14 once the count begins. Let's see how long they last by putting the same bulb in each battery. The first one to be exhausted was the yellow one in 1 hour and a half, so that is 450 real milliamp hours. The orange battery was exhausted after 3 hours and a half, so the battery is 1050 milliamp hours. Now we're going to look at the internal structure. This should not be done without adequate protection. Goggles in case it explodes or short circuits, a mask for toxic gases, and gloves that I did not wear. You have to cut without going too deep so that it does not short circuit and there is a risk of explosion.